Hello everyone. So we want to talk about the first problem of INMO 2021. This is the Indian National Math Olympiad. We will first discuss the problem, the statement of the problem and what it means. There are two R positive integers given to us, and these are m1, m2 up to mr and n1, n2 up to nr, and it is given that m1 mi nj minus 𝑚𝑗 𝑛𝑖, this absolute value is equal to 1. This is for all pairs ij, I comma j. So for example, if we have r equal to 3, this is just an example, then we have three numbers m1, m2, m3 and three other numbers n1, n2, n3, and by this condition, the one right here, we would be able to say that m1, m2 minus m2, n1 absolute value is 1, m1, n3, m3, n1 absolute value is equal to 1, m2, n3, m3, n2, this absolute value is equal to 1. So that's the condition of the problem that is given, and I gave you an example for the case of r equal to 3. We want to find out the largest possible value of r. Find maximum possible value of r. That's the goal. And if you want to try this problem, I suggest that you pause the video now and use the following hints to try the problem. So this is a second section about hints. In the third section, we will give you the solution. Think about parity of the numbers. So if I have one number, it can be either even or odd if there is one number. If there is one number, and if you randomly choose one number, it can be either even or it could be odd. If there are two numbers, if there is a pair of numbers, let's say AB, it could be even, odd, even, odd, even, or it could be odd, odd. Really, four types. Four types. Now, all ordered pairs are of one of these four types. So can you now use this hint and give this a try? Finally, let's go ahead and work with the solution. Well, the solution is something like this, that suppose you look at m1 n2 minus m2 n1. The absolute value is 1, means this is either 1 or minus 1. One of these two numbers, right? If the absolute value is 1, it means this value is either 1 or minus 1. So notice that m1 and m2 cannot have a common divisor except 1. Maybe I should write that. Why not? Because if 2 divides m1 and 2 divides m2, then you could take 2 common, and that would mean 2 divides the left hand side, which would mean 2 divides the right hand side. But no other integers except 1 can divide the right hand side. So nothing, not 2, not 3, not 4, no other number except 1 can divide both m1 and m2. In fact, if there are m1, m2, mr numbers, then the m1, m2 GCD will be 1, GCD of m1, m3 will be 1, and so on. Any pair of numbers 𝑚𝑖𝑛𝑗 is equal to 1, where I is not equal to j. So in technical terms, we can say the numbers are pairwise coprime. The numbers are pairwise coprime, right? And in fact, we can say that m1, n1, this GCD is also 1, using the same logic, m1 and n1. In fact, GCD of mi and I is 1. So this is the information that we can directly have from these equations, right? Now the question is, what would be the parity of m1 n1? So this is the last part of this proof, the parity of m1 n1. Suppose there are a bunch of numbers m1, m2, mr, n1, n2, nr. Now take the pairs m1, n1, m2, n2, like this up to mr, nr. We know that the GCD is 1 or they are pairwise coprime. So what could be the parity of these pairs? Okay, they could be even, odd, odd, even, odd, odd. Now they cannot be both even. m1, n1 cannot, or mi, ni cannot be both even, because we just established that this pairwise GCD is 1. So they cannot be both even, because then the pairwise GCD will be 2 or something else. So this condition will not be valid. They cannot be even. So only the three other possibilities are even, odd, odd, even, odd, odd. Okay, great. So they can be of only one of these three possibilities. Now the question is, can 𝑚𝑖𝑛𝑗 and 𝑚𝑗𝑛𝑗 be both even, odd? Can both of them be even, odd? Is that possible? Or can both of them be odd, odd? Is that possible? Can both of them be odd, even? In other words, can two of these pairs have the same parity? Can two of these pairs have the same parity? So let me check the case of even, odd. What if 𝑚𝑖 and is even, odd, and 𝑚𝑗 is also even, odd? What happens then? Well, we will have let's look at 𝑚𝑖𝑛𝑗 minus 𝑚𝑗𝑛𝑖. Let's look at this figure. This is even times this is odd minus this is even and this is odd. So this thing becomes even. Why? Because this is even and this is even, so even minus even is even. So clearly this quantity right here is even if both of these are even, odd. But how can that be? Because this we know is either 1 or minus 1. So it can't be even. That means both of these two quantities cannot have the same parity. In fact, the same logic would hold for odd, even, and the same logic would hold for odd, odd. In each of those cases, if both of these quantities, both of these pairs have the same parity, then the difference would be even, which will be contradictory because we know the difference is 1 or minus. The difference is 1, and if you subtract, it's 1 or minus 1. Which basically tells us that there could be at most 3 such pairs. Because if there are 4 such pairs, then 2 of them will have the same parity. Because there are 3 distinct parities, if there are 4 such pairs, by pigeonhole principle, 2 of them must have the same parity. So can R be equal to 3? Is it possible? Can there be M1, M2, M3 and N1, N2, N3 numbers, positive integers, which work with these conditions? Well, that is for you to find out. That's the last part and the easiest part. Find me examples of 3 numbers M1, M2, M3 and 3 numbers N1, N2, N3 such that the condition of the problem holds this particular condition. Okay? Okay, so this was a very beautiful problem. It was based out of parity. We will see each other in the next problem. Till then, stay well and keep on doing great mathematics.